It's a pleasure to be here. I apologize, I'm going to speak in English, but hopefully the translation works if that works for you. So today I do want to talk to you about the future more than where we are today. So let me start. I'm going to get your input in a few slides, so you have your phones open. I need you to do a Menti for me. But to start with, we introduce myself as the Managing Director of Center for the Edge. Center for the Edge is a futures think tank. We started in San Francisco about 15 years ago, and 5 years ago I moved to Singapore to bring it to Asia. And the big question we ask is, what should be keeping you up at night? Not what keeps you up at night today. Today you're worrying about the things that you need to deliver next week and next month and the next quarter. But what should you be thinking about? What's around the horizon that you should be paying attention to? And that's what we take to boards and CEOs. Now, the reason we call ourselves Center for the Edge is because we believe that all disruptions emerge from an edge. The edge of technology, like AI, or quantum, or space, today, the three topics I'm going to talk about, or the edge of society, the edge of demography, young people, Asia, how they behave, how they think, how that influences technology as much as technology influences their behavior. So that's what we do here. My second role is I lead innovation for Deloitte Asia Pacific, which means I take all of this information that we put together and help our clients with and apply it to ourselves as to what investments Deloitte is making into the same topics. So with that, let me get started. There are 5 topics that we broadly cover for Center for the Edge: digital disruption, innovation, transformation. How do companies and governments and institutions change and evolve? Future of work, working and workers. We have to separate those things: work, working, and workers, all 3 of that. Sustainability and resilience, the next internet, what's emerging now, and being human in a digital age. I think that's a critical one, the last one, that the world has become more and more digitized. What is the role for humans in this context? We write lots of reports, we do lots of talks like this. We essentially help leaders like yourself navigate better into the future. So let's get started with the Menti. Are you guys all familiar with Menti? Go to menti.com if you don't mind and use this code 1145-5403. And I'd like your input before I go forward so I can tailor my comments better. What tech trend is going to make the most impact in the next 3 to 5 years? So I want your opinions on this. So would you mind going to Menti and putting your thoughts into here? So while I do that, Thailand's a very familiar place, even though it was far from the US when I was there. I used to get back here at least 2 to 3 years, every 2 to 3 years, and now in Singapore I get here every a few times a year, both professionally and personally. We can switch to the Menti and see what you're getting up here. And what I found here is people here are very willing to try new things, and they're very digitally savvy, and that's good. So the people are ahead of the curve in terms of digital adoption. What's not good is the regulator and the policy side might be quite behind, and therefore they are more susceptible to scams and cybersecurity. So that's something I think this room should pay attention to. Okay, we're getting some things here. AI, quantum, digital twins, biotech. Quantum is big again. Smart farming. Otherverse, yes, the metaverse, digital, AI, robots, blockchain. Crypto, yes, this part of the world is actually, Thailand's big into crypto. LLMs. Okay, so there's enough information here for me to move forward with. And I won't disagree with any of this. So let's go back to the slides if you don't mind. So, in terms, let's start with AI, right? So let's start with AI as the main topic because it is the topic of the month, the topic of the year, and probably the topic of the decade before the next thing comes along. But I want to frame our trends, AI, quantum space, crypto, all of that we talked about, into 2 ways of looking at it. One, elevating forces, the evolution of innovation and technology that pushes things up, right? Interaction, information, and computation. And then grounding forces, things that you need to take care of, the cost of running things and the risk of what could go wrong, managing those risks. So if you look at this, interaction is kind of usability. Information is data and data quality. Computation is a processing power. These things are driven by technology trends with the likes of Google, NVIDIA, IBM, Microsoft, Meta, all those guys pushing into it. Those are the elevating forces. Those are the things that speed up. Grounding forces are business technology, which is the cost of actually implementing all these technologies, cyber and trust, cyber security, and co-modernization, adopting these technologies into your own institutions. These things ground us. These things slow us down, but rightfully so, because if we move too fast, we could break things too much. So you got the push and the pull. In this context, I'm going to talk to you today about three topics: AI, quantum, and space. But specifically within AI, I'm going to talk about agentic AI. I'm sure you've heard that word. On quantum, I'm going to talk about quantum readiness. On space, I'm going to talk about space for non-space. So let's get started. What's next for AI? Three things we believe we're going to see in 2025 in the evolution of AI and generative AI. First is scale AI. We've seen a lot of experimentation over the last few years, the last 2 years since generative AI came into play. And now we're going to see much more into scale operations. We're going to see it from examples here and there to organizations and institutions like yourself embedding AI into everything you do. Second, which is my topic today in this context, is agentic AI, intelligent digital workforce. These are digital twins for us humans for what we do today. It's a much bigger step from what we're seeing in generative AI. Third is AI everything. Products, services, applications, they're all going to get AI embedded into them. And you won't even see it. It'll be invisible. It'll be in the background, but AI will be embedded into all of this. So those are the three topics. And I'm going to focus on agentic AI. One of the reasons this is relevant is people are already adopting this. This is from a recent survey we did. 90% of students in Southeast Asia have used generative AI. 70% of employees have used generative AI, right? So Southeast Asia is second out of 9 locations for AI use. The general population is already jumping into all of this. We had to provide the infrastructure and the security around it. So let me show a quick video to get us started on the agentic AI topic.
Agentic AI is transforming every enterprise, using sophisticated reasoning and iterative planning to solve complex, multi-step problems. AI agents help marketing campaigns go live faster with instant insights, helping optimize supply chain operations, saving hundreds of millions in costs, and reduce software security processes from days to seconds by helping analysts triage vulnerabilities. What makes agentic AI so powerful is its ability to turn data into knowledge and knowledge into action.
So the fundamental thing that agentic AI is doing different from generative AI is not just performing a task. You're not just asking it one thing and it performs that. It does a task, gets the information from it, gets insights from it, and does one more thing. It does multi-step workflow processes to get to the final outcome that you want to, without any human input in between. Right? This is pretty incredible what they can do. So they're not just interacting with you, they're actually getting to an endpoint without you interacting. A simple example is you could ask it to say, I need to get from here to here on this date with this place. The sort of thing that we ask generative AI from a travel standpoint. Say you want to get from Thailand to San Francisco on a certain date and come back, but not only will it find you the best things, it'll know your preferences, it'll check with other things, it'll check different options and actually book the flights for you. So it's going the whole way through, right? So let's look at a little bit of what's different. In the first column talks about generative AI and LLMs today, and this is AI agents. In the use case, it's automate tasks. It takes one single task and automates it, right? That's what LLMs and generative AI do today. When it comes to AI agents, they automate the entire workflow process. It'll do multiple tasks rather than one. From a planning standpoint, generative AI is not capable of planning or orchestrating workflows. That's exactly what agents are supposed to do. Agents are like very, very simple human beings doing the work that we do today. They can stitch together multiple things. Memory, today LLMs don't carry a lot of memory. In AI agents, they will have memory over time. So they will, over time, get better and better because they know your preferences, they know your behaviors, and they will adopt to that. Tool integration, they are designed, LLMs are single task, agents are supposed to work with other tools, and that goes to another whole aspect of multi-agent integration. Data integration, LLMs tend to be static, AI agents are dynamic and immediate, so they can go get current information. And accuracy, LLMs can't do much. AI agents, you can write into it that they validate their own information multiple times. So they'll be more accurate than the other ones. So what happens next, and so we're seeing early cases of agentic AI today in the marketplace. What we're going to see in 2025, towards the end of this year, is multi-agent teams, which means agents working with other agents. You will have your own AI agent, which will work with another AI agent and another, either outside your firm or institution, or even within your own institution. So this is a big step. Essentially, they're going to be doing all this work without human intervention, which means you can get to hyper-personalization, continuous fine-tuning, improved customer satisfaction, and enhance scalability, right? This is a big step, and it has big implications, both good and bad. Now, one of the big issues with AI is trust. These headlines just are a few among many that talk about how trust has been betrayed as AI gets more and more embedded. And that is only going to get exacerbated as we move to agentic AI. Because think about this. Go back to the grounding forces, right? Let me go back to this slide. If you have issues today with just generative AI and asking a question and getting an answer, those same questions get amplified as they do multiple tasks in between. Right? So the issue, if you're not taking care of your privacy, if you're not taking care of your cybersecurity now, it only gets amplified when you get to agents who are going to be using that bad information to actually do tasks rather than give you an answer. So that means that from a business technology standpoint, you got to put the guardrails in there. From a cyber trust standpoint, you got to make sure that the right data goes in. And from a core modernization practice, you got to make sure that you have strong, trustworthy AI practices installed in your institutions. Because without that, you're going to amplify it. Now, what does this mean for adoption? It's no different from what you do with AI today. You want to validate the results, you want to encourage follow-ups, you go back and forth, you tailor your queries, and use high-quality data, right? That's where you can come in, because your institutions have good, high-quality data that you want to provide to feed these engines. And the don'ts are don't expect perfection. AI is not meant to be perfect. Don't outsource human reasoning. Even though these agents can do a lot of work, humans do need to be in the loop in the proper way. You cannot disregard contractual needs, and you can't blindly trust the results, right? These are still tools to help us do our work more effectively. So that's AI and agentic AI. We're going to see a lot of this in the coming year. Let's go to the next topic, which is on quantum and cryptography. Okay, question here. I'm not going to do another Menti, but a quick question. I want to show of hands on the topic of quantum just to see kind of what level of awareness we're working with here. So do you think, when you think of quantum computing, it can solve problems instantly? That's A. It exists only in theory, not in practice. That's B. C, it can process multiple possibilities at once. Or D, it'll replace classical computers entirely. So those are the four, A, B, C, D, right? A, can solve problems instantly. 2, that it exists in theory, but not in practice. C, can process multiple possibilities. And 4, so how many people think that it's A? Show of hands. How many people think it's B? That it can exist only in theory but not in practice. How many people see in C? Okay, and how many people think it's D? A few Ds, no A's and B's, a bunch of C's. You guys are pretty good. It's actually C. It can process multiple possibilities in space, right? It can solve particular problems really well, but not all problems. So it won't replace classical computers the way we know of it. Here's a quick video to explain how quantum works.
In our mobile, globally connected world, sustainable, efficient logistics are becoming an increasingly complex challenge. One that also poses problems for navigation and data processing. Where conventional processors hit their physical limits today, quantum computers could find solutions in the future. This is because they are based on the coupling of quantum states. Conventional digital computers calculate with individual bits, which always take on one of two possible states, 0 or 1. They work like on-off switches, which, when combined to create logical circuits, can execute computer functions. Conventional computers use serial operations. To find the optimal route in a complex road network, for example, a digital computer would calculate each route section in succession. Although they do it quickly, it is still simply consecutive. In contrast, quantum computers are masters of multitasking. They would calculate all the possible route sections at the same time, in parallel, and find the perfect route.
That's a really good explanation of how quantum works, right? Like it mentioned, our current computing world is built on zeros and one, digital, on or off, black or white. Quantum computers, qubits, is based on physics, where all possibilities can exist at the same time. This is like the metaverse stuff and that you see in cartoons and Spider-Man. All it's like that. It can do everything all at the same time. So you can find all the solutions at the same time and get to an answer faster. So it doesn't replace classical computing, but for certain types of problems, it does it really, really well. And one of the problems it does really, really well is it can break current cryptography. And that's what gets to my next piece here. So when you think of quantum, not quantum computing, quantum, we break it down into 4 parts. One is quantum computing, building the actual computers that can do these calculations using qubits. And the big giants, Google, IBM, and a few startups are working on this problem. It's still at a research level, but they're advancing really, really fast. Second is quantum preparedness. Quantum preparedness is going back to that problem I said before. If your current cryptography can be broken by quantum computers, what do you do in that context? If you are running a financial institution, if you're running critical infrastructure, this is absolutely critical that you are prepared for a point when a bad actor can come in and break into all of what you have. Quantum sensing is ultra-sensitive sensors. It's a small but important piece, a niche piece. Same with quantum communication. It's a small but important piece. Our focus is on quantum computing and quantum preparedness, and today I'm going to talk to you about quantum preparedness. So, cryptography is embedded in everything that we do in data today. Digital assets, telecommunication, signatures, payments, geolocation data, everything we do today is anchored by cryptography. And this cryptography can be broken by a quantum computer. We don't know when that's going to happen. It could be 3 years from now, it could be 5 years from now. But listen to this next clip as to why it's relevant to start protecting it today. Let's see.
Right now, some nation states and individual actors are intercepting and storing lots of encrypted data, like passwords, bank details, and social security numbers. But they can't open these files, so why are they doing it? Well, because they believe that within the next 10 to 20 years, they will have access to a quantum computer that can break the encryption in minutes. This procedure is known as Store Now, Decrypt Later, or SNDL. And it works because there is information around today that will still be valuable in a decade. Things like industrial and pharmaceutical research and top secret government intelligence.
So if you thought that today's scams are bad enough, this is what scammers are doing today. They're collecting and storing information now to be decrypted later when there's a quantum computer available. If we think about Thailand, and the previous gentleman from Google mentioned this too, in the context, they're very adept at using all these new technologies and adopting all things digital, but they're also quite susceptible and vulnerable to the digital risks. And these are just examples of that, right? So as Thailand gets more digitized, this becomes more important that we encrypt these things. And the reason we need to do this now is because in the next 3 to 7 years, and that's our current prediction, a quantum computer is going to be viable, which is going to be a stable computer that can do quantum computing. If that's in the hands of a bad actor, they can now start breaking into all of your critical elements, whether it's finance, whether it's critical infrastructure, and that's an extremely dangerous thing. So you need to start now embedding quantum preparedness, post-quantum cryptography into your systems. Last year, the National Institute of NIST in the US came out with their post-quantum cryptography standards. Europe came out with another set as well. So these two set of standards are going to be the anchor for what you need to establish for the future. So in the immediate term, you need to take an inventory and assessment of where you're at and what needs to be secured. And in the near term, you need to start applying post-quantum cryptography towards your most critical assets. And over time, you need to monitor this to make sure that you're secure in where you need to be. So that's the second topic, quantum, but really focusing on quantum preparedness. Third topic is space for non-space. Now, in this part of the world, we haven't yet sent rockets up in the air. When you think of space, you normally think of SpaceX, you think of Starlink, you think of all the amazing stuff that's going on that expanded quite fast. But we can do a lot with looking down on Earth observation. And that's a big opportunity for space, for non-space. Now, a quick Menti here as well, or not a Menti, just show of hands. Which country launched the first privately, not publicly, privately owned satellite? Singapore, Philippines, Malaysia, or Thailand? So Singapore, few hands. Philippines, few hands. Malaysia, no hands. Thailand, lots of hands. So either way, you're winning, right? Because I mean, this is a gimmick. You're winning because it's Thailand, but yes, it is Thailand. In 1993, Thaicom was the first privately owned satellite in Southeast Asia to go up in the air. Way before that, Indonesia sent Lapan 1, but it was a government communication satellite. So Thaicom was the first one in Southeast Asia. And you guys are doing quite a bit on this topic, so if you didn't know, and there's a lot more you can do with this. But a quick video to get us started as to why this matters, why Earth observation matters.
By bringing industry together with the brightest innovators worldwide, we've co-designed commercial solutions using space to make massive leaps in how we farm, fish, mine, build, connect, explore Earth and space, respond to climate change, natural disasters, health emergencies, manage cities, ecosystems, roads, water, energy, invest in the future and the entire planet. Well, we're getting there. Find out more on gravitychallenge.space.
So about a month ago, we released a report on the Southeast Asia space economy, overall looking at the economy around space. And we feature Thailand in this. So I'll show you a few slides from here in Thailand. But the overall headline is that if we were to adopt Earth observation technologies that exist today, over the next few years, from now to 2030, the economic value of that is 100 billion. That's B with a billion, 100 billion US dollars to Southeast Asia. It's a big, big number. That means it's worth leaning into. And Thailand could lead in some of these things. And what you're referring here is the idea of new space. It's not sending rockets up in there, but it's looking down on Earth and communicating better. Right? That's what we can do more of. And it's bringing the private sector into play here. If you look at how things have evolved in the 60s and 70s, it was a Cold War between Russia and the US, the two biggest countries in the world, economies in the world, fighting to send things up into space. Then it became more like NASA, JAXA, ISRO, but still very government-led. Now, it's Blue Horizon and SpaceX. It's all private companies. And all the startups, the satellites, all the looking down, it's all private companies, right? And that's accelerating what can be done here. And we have to. Thailand has to have a play in this, and it does have a play in this. So that's the why now of what you want to go after it. Another few more pointers here. In terms of understanding space, Thailand aims to be a global leader in space and technology. So one of the questions asked before is, where do you put your talent? What should we be investing in? Where do you take your manufacturing capabilities to? Space is a big topic that you can go into, because all of the aeronautical stuff that you need to create can be done here. All of the digital work, building the models to understand the data, can be done here. So I think you're well positioned to take on something like this. And you already have quite a good start here. 16 satellites launched, 220 million going into the THEOS-2 satellite program, lots of government entities involved in this, and lots of people involved in it already. Now, if you think of space, there are, click here, you got to understand the different satellite capabilities. The ones that are furthest out on Earth, enough to cover the whole Earth. Those are the geo satellites. Medium Earth satellites are more communication led. Not many of those. Today's focus is very much on low Earth orbit. So when you hear about Starlink sending out tens of thousands of satellites, that's all onto the low Earth orbit. And now the new generation of very low Earth orbit ones also coming into play, where they're actually fueling themselves to stay at about 200 kilometers. But when you have more and more satellites here, you get more and more data they can use. So think about this as just another set of data. If you can combine this data with terrestrial data, what's on the ground, you can get new insights that you couldn't before. Yesterday, we had a meeting with GISDA, and hopefully we'll be working with them for building a platform for Thailand to use all of this data that it already has and to collect more data that it doesn't from all of the different satellites up in the air. So that's a big opportunity there. And here's a Thai company, a Thai startup that's doing something with it.
One company benefiting from the thriving startup scene is Recolt. Co-founded by Orkrit Unahalakaka and Usman Javid, the company created an app that helps smallholder farmers in Thailand and Pakistan to improve their yields using AI and machine learning. The app also helps farmers secure bank loans, something that in the past was difficult for many. Since 2019, Recolt has had nearly 1 million farmers using its platform, and nearly half of those users were in Thailand. Orkrit, thank you so much for talking to me. So you essentially built a tech platform that would empower the farming community and in the process take away the exploitation by the middleman.
So here's an example, a local example of a company taking technology, taking advantage of it. They don't have anything up in space, but they can build new capabilities and new opportunities for everyone on the ground. And that's exactly what you want to do. You want to expand and reach new and connect new markets. You want to unlock actionable market insights and then drive real-time precision. So what you can do and what you will be able to do with space over the coming years, space data, is going to be incredible. So that's another thing to watch for. So that's the end of my talk. 3 things. We talked about AI, we talked about quantum, we talked about space. But in each one, I focused on a sliver, just one small part, right? On AI, look out for agentic AI. These are intelligent digital workers like you and I that we'll be working with much more in the future. Learn how to work with them, learn how to use them, but be prepared for the issues that come up. If we don't fix how we do things today, it'll only get worse when it gets to agentic AI. Second is quantum readiness. While quantum computing might be a few years out, you got to start the journey today. Because if you don't secure your critical infrastructure and your critical data pieces today, it's going to be an issue a few years down the line. Third is space for non-space. We had to start thinking of space beyond sending rockets up in the air. There's a lot of data and insight that can be gained from looking down on Earth. So that's a whole new spectrum. And this matters absolutely for where you can point your human resources in this part of the world to pay attention to. Thank you.